So the first thing that we need to do is find these primary trig ratios for this triangle and then find out what theta is. So let's take a second and actually apply kind of what we already know here using our SOHCAHTOA acronym. So in order to find our primary trig ratios, we've got sine, cos, and tan. So we know that sine of the angle is equal to opposite over hypotenuse. I know that cosine of the angle is equal to adjacent over the hypotenuse. That's the ka part in SOHCAHTOA. And we know that tan of the angle is equal to opposite over adjacent. So I have a triangle where I know all the sides. So let's just start to fill in what some of these ratios actually are. So here's my reference angle, which means opposite the reference angle, here's my opposite side. The 5 would then be my hypotenuse, opposite the right angle, and that leaves the adjacent to be the side that's touching the angle or touching the reference angle. So in this case, sine of theta is going to work out to be opposite over hypotenuse, or it's going to work out to be 4 over 5. Cosine is adjacent over hypotenuse, it's 3 over 5. And tan is opposite over adjacent, which is going to be 4 over 3. So I have my trig ratios. Now, normally when we get them, we have to write them out in decimals. So let's divide those numbers through and come up to be what they were, or what they are in decimals. So 4 divided by 5, that's 0.8. 3 divided by 5, we have 0.6. And 4 over 3 is 1.3 repeating. Now, here's kind of the part where we have to check your calculator and make sure that you can punch in this information okay. So what I would like for you to do on your calculator is we're going to take it step by step and we're going to check out all 3 of them. So because we're looking for the angle, we actually have to find the inverse of the trig function that we have. In other words, I need that second function button on your calculator because I need to get to that sine negative 1. So sine negative 1 of 0.8. And then let's figure out what theta is. The biggest thing is on your calculator somewhere it should say that you're in degrees. It'll either be a capital D, it'll say DEG, or it might even say the whole word degree. We can't be in radians or gradients, otherwise you'll get an incorrect answer. So let's figure out what sine inverse of 0.8 is. So on your calculator, sometimes you have to punch in the number first and then hit second function sine. Other times you have to hit second function sine and then the number. It just depends. Normally, if your calculator will show you the numbers as you punch them in on the top of the calculator, like if it stores numbers in your screen. So if I hit second function and go into mine, and I have this sine negative 1 of 0.8, I'm getting 53.13 degrees. So make sure that you can punch in your numbers to get that same value. That's going to be really important. After that, let's try cos. So cosine, now with cosine we had 0.6. Okay, so let's see if we can do second function cosine and punch in 0.6. And we should get the same answer again, 53.13 degrees. That tells us that we're on the right track. And one more last one, let's try tan. Hopefully we get the same thing, tan inverse 1.3 repeating. And so when you punch this one in, punch in a whole bunch of 3's together. So second function, tan of 1.333333, and we're getting 53.13 degrees again. Which makes sense because in every case we're finding the exact same angle, so we should get the same number. So what this actually tells us is that we don't need to find every single one unless it asks us to set up the ratios. But basically, we just need to have two side lengths to find an angle. Any two will do, because we can either use the opposite and the hypotenuse, we can use the adjacent or the hypotenuse, and we can use the opposite and the adjacent. So all of them will help to find out what the angle is. So one more example to solve triangle ABC, which is all the angles and the sides. So we've got angle A, angle B, and angle C. We know angle C is a right angle, and I have two of the sides already. So we know the hypotenuse is 10, and one of the side lengths, in this case B, is 8. So we know two sides, so we can find the third. And we can do that using Pythagorean Theorem, which is something that you would have learned quite a while ago that deals specifically with right angle triangles. So we plug in B, we plug in 8, in C we plug in 10, and then we can see that really we have to subtract those, right? 8 squared is 64, 10 squared is 100, and 100 minus 64 gives us 36, which means that we can find that A is 6. Then we can use what we know about trig to really solve for angles A and B. And I could have done that anyway without finding A, but if we know all three sides, that just means that we really can have a little bit of choice in what we want to pick. So let's say, for instance, that we wanted angle A first. Then let's use the ones that were given in the problem. So if I'm solving for angle A, and I'm given 8 and 10. 8 is the adjacent side. It's the side touching the angle that's not a hypotenuse. And 10 is the hypotenuse. That's the one that won't change anyway. So A and H. If I think about my acronym, with A and H, then I have adjacent over hypotenuse, I have cos. So the cosine for angle A, cosine of A, is equal to adjacent over hypotenuse. The cosine of A is equal to the adjacent side, which is 8, over the hypotenuse, which is 10. Cosine of A is equal to 0.8, which means now I'm looking for the angle, so A is equal to cos inverse of 0.8 degrees. So A, in this case, if I do on my calculator again, looking for that second function button for cos, so second function cosine of 0.8 degrees gives us 36.87 degrees. Now we know that the sum of the angles in a triangle add up to equal 180. So if I were to add the 90 degrees on here and just subtract 180, I know I'm going to get 53.13 degrees for the other angle, but let's actually calculate it just to verify. So now if I wanted to find B, and I have 8 and 10. So if I'm looking for angle B, here's my opposite, here's my adjacent. It looks like in this case now for SOHCAHTOA, I have opposite over hypotenuse, not adjacent. Opposite over hypotenuse, I have sine in this case. So sine of B is equal to opposite over hypotenuse. Sine of B is equal to, looks like 8 over 10 again. And so you would think maybe it'd give us the same answer, but it's a different trig function, right? The first one was cos, the next one is sine. So B is going to be second function sine, the inverse of 0.8. So angle B in this case of 0.8 is going to give us our 53.13 degrees. And again, I encourage you to plug in those numbers in your calculator so you have an understanding on how to do them. That's going to be really important.